Hi, welcome to your lesson on simplifying rational expressions. Let's begin with some basics. This is a rational expression. A rational expression is one that can be expressed as a fraction, and here we can see this is a fraction. To simplify this, we can basically look at it as a product. So the top is 3 times 15, the bottom is 5 times 15. Now we look for common factors which we can eliminate. We see 15 on top and bottom, those can be eliminated because they actually make 1. And we're left with 3/5. Obviously, that's basics. You have reduced fractions in the past. It's important, though, that you consider reducing these like this into factors, because that will help us when we move into algebra. All right, so these are on your notes page, by the way. So let's continue on the next one on your notes page, which looks like this. This can be rewritten as 4 times 3a, and on the bottom, just 1 times 3a. So we have this common factor, top and bottom. Common factors can be canceled. If those are eliminated, we're left with 4. And again, doing this division in the beginning may have been quite obvious to you. However, again, let's concentrate on writing factors so that we can see the canceling of that common factor. All right, look at this last one here. What cancels? If you notice, you have a common factor there. So now that we have more variables in here, but the same principle applies. We have a x plus y here and an x plus y here. Those common factors can be canceled or eliminated because they make 1, and we're left with x minus y over 4. Okay, let's try a few more. So here, reduce this one using the same method. Well, 64 is 4 times 16. 80 is 5 times 16. We have a common factor on the top and bottom. Those can be canceled. We're left with 4 over 5. Next one. Let's see if you can write it out with common factors. So question's going to ask you, what is the common factor on the top and bottom here? Hopefully you are able to break that up into a squared times 15a, this one here. And the bottom is 4 times 15a. So the common factor that's going to cancel is 15a, top and bottom. And we're left with a squared over 4. All right, this one has a lot more going on, but there are some common factors there. Let's see what you can eliminate. Well, there's an a plus b there and there also. Then we have, was there anything else? Yeah, e and f, those cancel as well. So we're left with just this factor and this factor on top, and just this one on the bottom. So we can write it like this. And we have simplified that fully. Let's look at a few more here. Now these ones will require factoring. We have x squared minus 9. You may recognize this as a difference of squares. That factors into x plus 3 times x minus 3. On the bottom, we still have this. So now you look at this, and you think, what is a common factor, top and bottom? Well, we have that common factor of x minus 3. Those can be canceled. That means this simplified fully is x plus 3. Try the next one using the same approach. Hopefully you notice that one is exactly like the upper one. We have a difference of squares, which factors into this. But on the bottom now we have x plus 3. So it's just the opposite factor there. And this time the x plus 3 and the x plus 3 will cancel. And we're left with x minus 3. Okay, try this bottom one here. It's a little bit different. You're still going to have to factor the top. Let's see what you get. Well, if you factor the top, you notice there's an x here and x squared here. That means an x can be removed from each of these. So we factor out the x, and we end up with x times x plus 3. Now we have a common factor of x plus 3 and x plus 3 here. Those can cancel, and you're left with just x. Okay, let's take it to the next level now. Notice these directions have changed. We're going to simplify each rational or fractional expression. This is a rational expression. And it says state the restriction on x. That means the restriction means what values can x not be. And we'll talk about that in just a moment. First of all, do you see a common factor in the top here? So what is the common factor you can pull out of both? Hopefully you noticed an x to the 4th power can be divided out of that and that. So if you remove an x to the 4th, you end up with x to the 4th times 5x, which would give you that. And then x to the 4th times 3, which would give you this. So that has been removed. Now we notice there's an x to the 4th here and here. So those are common factors. That one can be canceled, and so can that. That means we're left with 5x plus 3 and 2 on the bottom. All right, now in terms of the restrictions, we know that x cannot be 0, and you're thinking why? Over here, x can be 0. If you put 0 in here, that's okay. But looking back at the original, and this is what we have to do with these, look at the original. You may know that you cannot have any fraction with 0 in the denominator. So you're looking at the bottom here and thinking, what value would go in here and turn this whole denominator into 0? Well, the only way you can make all of this 0 is to make this x value 0. Therefore, x cannot be 0, because that would make this a fraction with 0 on the bottom. So that is what we call the restriction on x. X cannot be 0. Let's look at the next one. So here, this one might be a little tougher to see, because right now there are no common factors. We have a minus b, but here is b minus a. And this is a plus 2b, and this is a minus 2b. They look similar, but they're a little different, and that negative matters. So what I would suggest here is look at either one of the bottom ones there and take a negative out of it. So what I mean is this. The top has remained the same. The bottom, out of this second factor, I pulled out a negative 1. So if I take negative 1 out of there, then both of these, their signs change. So notice the b went from being positive to negative, and the a went from being negative to being positive. If you multiplied this negative 1 back in here, negative a, positive, you'd end up back at this. So by removing that negative 1, now we have a common factor, a minus b, a minus b. So those can cancel. Simplify the rest. This is a plus b, 2b on top. And on the bottom, if you take that negative and multiply it through here now, this negative becomes a positive 2b, and this positive a becomes a negative a. So we end up with this. So that might be a little tricky if you've never seen something like that before. But please remember that shortcut there. We do that quite often with pulling out the negative like that. So here's this. Now, what are the restrictions on a? This one we're going to go a little further. Look at the beginning one. And the way to find out how the bottom becomes 0 is by taking each factor and setting it equal to 0. So our first factor, what am I doing here? A minus b equals 0. Let's see. A minus b. So if you took that factor, then even if the negative was pulled out, so here's the a minus b factor, right? I'd take that a minus b, set it equal to 0, then solve for a equals b. So when the a value is b, the bottom will be 0. So for example here, if you made this a value into a b, it would be b minus b, which would make this 0, and then the whole denominator would be 0. So a cannot be b. Let's look at the other factor in the bottom. Take that factor, also set it equal to 0, and now solve for a also. I decided to make everything solving for a here. You could have done the same thing and solved for b, but if we're solving for a here, you get a equals 2b. That means if the a value in the denominator here is equal to 2b, this will also become 0. So let's take that 2b here, and if you put 2b in for this a here, you get 2b minus 2b, which gives you 0, and the whole denominator will be 0. So we have found two things the a cannot be. So here's how we're going to write it. A, and this symbol here means is an element of, and then there's a stroke through it, means a cannot be. A cannot be anything in this set. So a cannot be b, and a cannot be 2b. Now this question is a little abstract with all the a's and b's, so if you don't quite understand what's happening here, just keep watching. The next example will be back to something you're more used to, and it might make a little more sense actually what's going on here. But anyway, we're showing what a cannot be. Let's look at the next one. All right, here we have a more standard kind of rational expression. We have a quadratic on top, quadratic on the bottom. So in order to cancel factors, well, we need to get factors first. To get factors, we should think, how does each of these factor? So looking at the top one, let's factor it using our factoring method. A times c on top is negative 10. 1 times negative 10 is 10. And then the b value is negative 3. Two values that multiply to negative 10 but add to negative 3 are negative 5 and 2. Those multiply to make negative 10. Those added make negative 3. So that top part must factor using those two. Let's look at the bottom now before we write out the new fraction. In the bottom, a is 1 and c is negative 35. So negative 35, a times c. Our b value is 2, so 2 goes here. Now two numbers to multiply to make this, but add to this. Those numbers are 7 and negative 5. Those multiply to make negative 35. Those add to make 2. So now our factored form is this. Again, here we factored the top part. and we had negative 5 and 2, so x minus 5, x plus 2. That is the factored form of this. On the bottom, I got this part here, 7 and negative 5, so here's our 7, negative 5. That has been factored. Now that both top and bottom have been factored, we look for common factors. And I see x minus 5 here and x minus 5 here. Those can be crossed out. They are common factors. So the final simplified form is just x plus 2 over x plus 7. And now you have to look at the restrictions. So again, with the restrictions, we look at the denominator here before the cancellation was made, and we say, what can it not be equal to? So we take this first factor equal to 0, and we find out x is negative 7. When x is negative 7, this becomes 0. When x is negative 7, this becomes 0. So x cannot be negative 7 because we don't want 0 here. And then you take x minus 5 and set that equal to 0, and you find out x equals 5. So when x equals 5, this becomes 0. So we don't want x to be that number or that number. So again, the notation for that is x, an element of, but we stroke it out. X is not an element, so x is not a member of this set of numbers. X cannot be negative 7, x cannot be 5, because those numbers would make this 0. So this example is a little more clear than the last one. Make sure you pause and really think about what happened here, and that you understand this before moving forward. Let's try one more then. So this one, give it a try. I'll give you a hint. The top just factors normally. The bottom, however, think about what can you do first? Can you take something out of all three of these first? Well, you definitely can. On the bottom, they all have x's in them, so you can factor out an x. And now you're left with a quadratic here, because this was a cubic to begin. On the top, now you have quadratic. On the bottom, you have quadratic. Factor both of those, see if anything cancels, and then decide what the restrictions on x are. So top one factored, we have a times c, a times negative 28 is negative 28, and the b value is negative 3 right here. Two numbers that multiply negative 28 but add up to negative 3 are negative 7 and 4. Those multiply to that, those add up to this. So here's what's going to help us factor the top. Now the bottom, a times c, 1 times 14 is 14, b value is negative 9. Two numbers that multiply to 14 but add to negative 9, negative 7 and negative 2 multiply to positive 14 but add up to negative 9. So factored form then, these ones here, negative 7 and 4, helped us factor the top. These ones here, negative 7 and negative 2, helped us factor the bottom. Now a common factor is x minus 7, cross those out, and we're left with this simplified form. So we've taken this and simplified it. Now think about the restrictions. For the restrictions, you look at all three factors on the bottom. So x equals 0, then this one, x minus 7 equals 0, and x minus 2 equals 0. When you solve the bottom two here, you'll get these restrictions. So x cannot be 0, it cannot be 7 when you solve that one, and it cannot be 2. So there's three restrictions because 0, 2, and 7 will all make this 0, and that's not good. All right, so there's all your examples. Hope that makes sense to get you started. There's a lot more to practice here, so try to simplify all those, giving any restrictions. Answers are given to you on that page. These should be not too bad. These are actually quite easy examples compared to what we did. And then on the back, there's a bunch more if you want to try. You will answer the question, what happened to the guy who jumped from a 100-foot tower into a large glass of root beer? By solving each of these and writing the letters in the correct boxes down below, you will answer this question. Enjoy. You can do it.